Ethel Rose Tangunan, Jomel Nagano, John Mark Adriano, a Bachelor of Science in Electrical Engineering, Section 3A.
Solar-powered home. So, meron tayo ditong 3 configuration. Meron tayong grid-tied, off-grid, and hybrid. Magiging focus natin din sa video natin na to is sa grid-tied lang. So, yung off-grid saka yung hybrid, din natin masyadong i-elaborate yan. So, etong si grid-tied, nakakonect siya dun sa utility grid natin. Tapos, wala siyang storage battery. Yung off-grid naman, hindi siya nakakonect or disconnected siya dun sa grid. Kaya, ang tawag sa kanya is stand-alone system. Tapos, yung off-grid is meron siyang large set of battery packs na yun dun nga ini-store yung energy or yung napoproduce na electricity. Tapos ito naman si hybrid, pinagsamang grid-tied sa off-grid kasi nakakonect siya sa grid tapos meron siyang battery backup. So, focus na tayo sa grid-tied. Ito yung description niya. Sabi nga natin wala siyang battery backup, so sa gabi hindi siya nagpo-produce ng power. Tapos, yung mga excess energy na mapoproduce niya is babalik dun sa grid or mapupunta dun sa grid. And yung grid-tied na to is nagsusupply lang siya ng electricity during the day or nagpa-function lang siya during the day. Tapos yung main purpose niya is to save electricity. So, para ma-attain yung zero bill is kailangan yung solar RE ratings ng solar power system natin is nagmamatch dun sa pagko-consume natin ng electricity. So, ito yung itsura niya. Ito nga, sabi nga natin kanina, kapag sumobra yung pagkaka-design natin sa solar panel natin compared dun sa nagiging consumption lang natin ng electricity, yung excess energy nga na yun or excess power is bumabalik dun sa grid. For example, yung load lang natin is 3,000 watts, pero yung solar RE ratings natin is 5,000 watts. So, yung bumabalik sa grid is 2,000 watts. So, dapat kung gano'n lang kadami yung load mo is yun lang din yung solar RE ratings na ilalagay mo. Or dapat mag-match siya para hindi na bumabalik sa grid. Kasi kapag bumabalik sa grid yung excess power, may ikot yung kontador sa net meter kahit palabas o papasok yung pagpapaikot din sa net meter is magcha-charge pa rin dun sa electric bill mo. So, kapag ganun, magbabayad ka pa ulit kaysa makatipid ka ng wala ka nang babayaran talaga. So, ito yung mga parts niya or basic parts. Meron tayong solar panel, syempre. Tapos may grid tie inverter. Pwedeng with or without limiter. Pwedeng square wave or pure sine wave. Merong DC circuit breaker. DC surge protection device or SPD. Syempre, meron din tayong AC circuit breaker. Meron tayong AC SPD, surge protection device. Tapos meron tayong time delay switch, TDS. Meron tayong DC, AC electrical wires. Itong tatlo na to is small parts lang, so hindi natin masyadong di-discuss ito. So dito lang tayo hanggang sa 1 to 8.
Solar panel, parts and functions. So the heart of the solar power plant is typically solar cell will only produce around a half volt. So by connecting them together in series inside the panel, a more useful voltage is achieved. So, ayan, ganito yung itsura ng solar panel na madalas natin nakikita nowadays. Yung mga parts naman na at least alam na natin, mga different layer ng solar panel and also the functions of this panel na natangan natin in previous presentations. So, naka-highlight dito na most solar panel rated 150 watts or below are rated as 12 volts, while larger solar panel are always 24 volts, so we should always not 24 volts. So pwede natin basahin yung dito. So let's put that for it. So solar panel can be connected together or create a solar array. The output of solar ray is computed much like a battery. So parang battery lang din pag-bit ng solar ray na yan. So kapag sa series connections, yung voltage niya is mag-increase while yung current niya is remain or constant lang. Then sa parallel naman, kabalik na rin niya, na yung current dito is mag-increase and sa voltage is mag-remain lang. So, ayun, may example dito, apply natin sa connection ng back. So, each panel of the next slide is rated at 12 volts and 10 ampere. Calculate the following: total voltage, total current, and total power. So, yeah, number one is yung panel natin dito is connected in series. So, yung ating voltage yan, so dahil naka-series siya, pag-addadin natin yung voltage niya na 12 by each panel, so meron tayo dito 36 volts. And yung current niya, dahil series na siya, is remain constant lang. So, meron tayo 36 volts and 10 amperes. So, yung power niya is 36 times 10 is equal to 360 watts. So, dito naman sa parallel connection. So, dahil parallel sa, so yung voltage natin dito is remain lang, which is 4 volts. So, yung current niya is pag-addin natin, meron siya 10 ampere per panel. So, ang equation ng 30 ampere. So, the power is 12 times 30 is equal to 360 ampere. Katulad ng sa series connections. So, ano pinagkaiba niya? Dito sa series connections, yung voltage niya is mas mataas kaysa dun sa parallel. So, dito sa parallel naman, ang mataas dito is yung current. So, next, dito naman sa parallel. Makikita natin na itong dalawang to is connected in series and ito rin series. Ang gawin mo natin is pag-addin natin to or i-compute natin yung voltage niya, current ng dalawang niya. Connect natin siya sa parallel. So, dito meron tayong 12 volts plus 12 volts is meron tayo dito 24 volts. Dito rin ganun din. And meron tayong 10 ampere per parallel. Natin ito. Red. Red. 24 tapos tapos yung current naman na 10 ampere na nakuha natin sa tig-dalawang na yan. So 10 ampere plus 10 ampere is equal to 20 ampere. Para nakuha natin yung power niya is 20 times 24 is equal to 480 watts. So ganun din dito, no? Ang series connection naman dito is yung dalawang nasa taas at dalawang nasa baba ang connection. So, pwede mo natin dalawang na yan. So, dahil series, 12 plus 12 volts is equal to 24 volts. Yung current niya is re-remain lang 10 amperes. So, dito rin ganun. So, nakuha natin natin 24 volts. No? So, yung 24 volts niya mag-remain din parallel dahil pag-connected siya. Yung current niya, 10 volts plus 10 volts is equal to 10 ampere plus 10 ampere is equal to 20 ampere. So, sa power niya is 20 times 40 is 480. So, same lang siya ng power but magkaiba sila ng voltage and ng current. So, next. So, ayan. Yung polycrystalline. May two types ng solar panel, polycrystalline and monocrystalline yung itsura niya. So, itong polycrystalline ito yung crystalline natin yung pinagkaiba. So, sa silicon arrangement, yung sa monocrystalline is pure silicon crystal. So, dito naman sa polycrystalline is marami siyang fragments ng silicon molded together. So, sa cost naman, mas mahal itong monocrystalline and mas mura itong polycrystalline. So, sa appearance, sa mono is black siya and kulay blue naman sa polycrystalline. So, pero karamihan daw sabi na ito mas gusto daw ng blue. Sa efficiency, more efficient itong monocrystalline and less efficient itong polycrystalline. Sa lifespan naman, tumatagal ng 25 to 40 years yung sa polycrystalline, 20 to 35 years lang itong polycrystalline. Sa temperature coefficient, lower temperature coefficient making them more efficient in the heat ng monocrystalline solar panel. And sa polycrystalline solar panel is high temperature coefficient making them less efficient in heat. So, next, inverter. So, yung parts and function niya. Itong inverter is siya yung device which convert DC output into AC, which is the standard used by all commercial household appliances. So traditionally, there is usually one central inverter in a solar system. A more recent invention has been the microinverter. Microinverters are connected to the individual solar panels so that each individual panel provides a high voltage alternating current. A grid inverter unique characteristic over the other types is it automatically shut down yung system when the power interaction. So automatically shut down siya kapag yung system kapag nagkaroon ng power interruption. So merong types ng inverter. So first, pure sine wave inverters. This type output voltage in the form of sine waves. Utilities also provides with sine wave output. Because of this, pure sine wave inverters are usually needed if you are going to be tied to the grid. Typically, you need pure sine wave inverters for sensitive equipment, katulad ng sa TV, mga ganun, light bulbs, appliances, katulad ng microwaves, refrigerators. So, next naman na type niya is modified sine wave inverters. Kung sa pure sine wave, yung AC power ay napuproduce by inverter, very close matches ang output sine. Dito sa modified sine wave inverter, the polarity absurdly switches from positive to negative. So, ayan, ito yung graph niya. Yung pure sine and modified sine wave inverter. So, itong pure sine yung kulay blue. Yan. And itong kulay orange naman modified. So, kung ang modified ay makikita natin na yung modified sine wave niya is ganyan yung type niya. DC circuit breaker. So parts and function. The DC circuit breaker, sometimes referred to as the PB disconnects, are placed between the solar panels and the inverter, or in some cases built into the inverter. DC circuit breakers act as automatic switch, disconnect the inverter from solar array. And also it may also serve as macro switch if there is need to turn the solar system off or isolate the power panel from the rest of the system. So next, the surge protection device or SPD, parts and function. The DC SPD are placed parallel to the DC CD. SPD generally protects the system from power surge, or more appropriately called voltage range settings. So SPD redirect this excess power to the ground. So F redirect to the ground. Modify interconnection within power levels versus susceptible to electromagnetically induced transients where power surge are also arise. Exposure to restricted voltage may cause catastrophic component damage leading to the system failure. So kapag ayun yan, yung voltage reasons na yan, maaaring makasira ng ating system. Kaya gumagamit ng DC surge protection device para maiwasan yun. Next is yung AC circuit breaker, RCDO type. So, parts and function. The AC circuit breaker are placed after the inverter. So, ilalagyan ko sa inverter just like a typical CB it acts as an overcurrent protecting device. So, isa siyang protective device due to short circuit and overloading. RCBO stand for residual current operated circuit breaker with overcurrent protection. It may also serve as manual switch if there is a need to turn the power system on. So, nilaging manual switch yan kapag yung solar power system natin is kailangan natin i-off. Next, AC surge protection device or SPD. So, AC SPD are placed parallel to the AC CB. So, nakaparallel connection siya with the AC CB. Just like the DC SPD, this serves as protection against attention voltage, but this time on the AC side of the PV system. SPD redirects the excess power to the ground. Multiple equipment connections on the grid, either internal or external, can be also be a cause of electrical anomalies where power surge could also arise. This time delay switch. This can also be called as power one delay. It delays a turning on of electronic device for desired time driver. So, ayun, dinidelay na yung pag-on ng isang electronic device kapag nagkaroon ng power interruption para hindi pa sila yung ating equipment or machines. So, itong device na to is nag-serves its useful purpose usually when brownout occurs. So, mas nagagamit itong device na to kapag nagkaroon ng power interruption or brownout sa atin. After brownout, your power have already been restored. There is the tendency of power surge which may damage the system if it is being turned on right away. To prevent this, time delay with switch delays the turning on of the system for a minute or even a bit more. So, syempre, pag nagkakaroon ng power interruption or brownout, so yung electricity natin at kababalik lang ng kuryente is hindi pa stable yung electricity dumadayo na pwedeng makasira ng ating machines, equipment, or mga appliances. So, itong time delay switch, nagagamit yan para ma-delay yung pag-on ng system ng mga ilang minuto o mas mahaba para maiwasan yung pagkasira ng ating system.
The net metering. What is net metering? Net metering allows customer of distribution utilities to install an on-site renewable energy facility that exceeding 100 kilowatts in capacity so they can generate electricity for their own use. Any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. The DU then gives a peso credit for the excess electricity received, equivalent to the DU's blended generation cost, excluding other generation adjustments, and deducts the credits earned to the customer's electric bill. Ngayon, din sa net metering, pwede ka na magtayo ng kahit na anong renewable energy sa vicinity nyo, basta wag na lalakas sa 100 kilowatts. Ito yung mga tanong about sa net metering. Is net metering already available in the Philippines? Yes. On 27 May 2013, the Energy Regulatory Commission adopted ERC Resolution 9 Series of 2013, approving the rules enabling the net metering program for renewable energy. This resolution was published on July 2013 in newspapers of general circulation in the country and took effect 15 days thereafter. Thus, the net metering rules took effect in the Philippines on July 24, 2013. Ngayon, yung net metering daw, pwede na siyang magpatayo simula nung July 24, 2013. The net metering program is available only to on-grid distribution systems or DUs connected to the transmission grid. Ito pa isa. What benefit will I get of into net metering? Ano daw ba yung benefit na makukuha? By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rate of savings realized on electricity generated for own use is equivalent to the DU's retail rate, consisting of charges for generation, transmission, system loss, distribution, subsides, taxes, and other charges. You also earn peso credit on any excess electricity exported to the DU equivalent to the DU's blended generation cost, excluding other generation adjustments. The peso credits earned is then used to reduce your electricity bills. Ngayon, kapag yung renewable source nyo, yung renewable energy is merong sumusobra, babayaran sa iyo ng distribution utility yon. So, ganun kainam kapag meron kang net metering, wala ka nang binabayaran, ikaw pa yung binabayaran ng DU pa isa. How will my DU meter import and export energy? The DU may opt to install two unidirectional meters, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. The DU may, at its option, install a single bidirectional meter that can meter both import and export energy if it finds it to be a more economical. The DU may also install a third meter in proximity to your RE facility to meter its total RE generation. The total RE generation shall earn for the host DU-RE certificates which DU can use to comply with its renewable portfolio standards obligations. So, eto, kapag nag-apply ka ng net metering, papalitan na yung kontador mo para kapag naglalabas ka ng power, di na sa'yo mismo mapasok yung mga bayarin. At nababawasan na din yung bayarin mo at ikaw pa yung binabayaran. Ito, who are qualified to participate in the net metering program? DU customers who are in good credit standing in the payment of their electric bills to their DU are qualified to participate in the net metering program for renewable energy. These customers are referred to in the rules of qualified end users or UE. So, ito, basta ikaw yung customer na walang record o yung nagbabayad ka ng tama sa oras, simula kang utang, pwede, qualified kang mag-apply ng net metering. Consequences of not applying for net metering. In the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the system is rated 5 kilowatts and the load consumption is only 4 kilowatts, the system will have an excess 1 kilowatt which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. Kung ikaw ay naka-solar setup at hindi ka naka-net metering, lahat ng power na lalabas sa grid, babayaran mo yan. So, ayun yung consequences. Tapos, ito isa, is there any other way besides net metering that a customer having solar power system producing excess energy during the day and yet will not pay for it? This can be achieved by using an inverter with limiter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without the excess being sent to the grid. Ito, meron pa daw bang any other way besides sa net metering? So, yes. Gagamitin na ngayon yung inverter with limiter. Ito. So, dito tayo sa circuit connections. Ngayon, dito, meron tayo ditong solar panel board. Meron tayo ditong positive and negative. Yung positive is yung pula, yung negative is yung blue. Tapos, is nakakonect siya sa input ng DCCB. Ito. Tapos, nakaparallel siya dun sa input ng SPD, DC SPD. Tapos sa ilalim nito is may output para yung transient voltage is mapunta siya sa ground, itong green na to. where meron siyang electrode. Tapos may output tong DCCD na to, which is nakakonect siya sa inverter. Itong inverter natin na ito. Tapos dito na tayo sa kabila. Dito sa galing sa service center, which is nakakonect dun sa grid, papunta dito sa wire ng metro, then sa ito na yung combined box. Na itong combined box na to, kadalasan wala naman sa mga bahay-bahay. Tapos after dito sa combined box, mapupunta naman siya din sa panel board. Dito, minsan meron din dito nilalagay yung mga electrician na circuit breaker. Tapos dito sa kulay natin is meron tayong red, black, tsaka green. Yung red is L, which is line. Itong N naman is neutral. Yung green naman is ground. Ngayon, dito naman tayo ulit sa panel board. Itong panel board na to is naka-series siya sa input ng RCBO. Then yung output na to, naka-series lang din sa naka-parallel na AC, SPD, at TDS. Itong TDS na to. With yung TDS is siya yung time delay switch. Tapos naka-series siya sa output ng TDS sa programmable delay switch. Ito. Tapos doon nakakonect siya sa inverter. So, ayun lang. So, dito naman tayo sa electrical wire sizing. Itong TW is thermoplastic wire, moisture and flame retardant. Dito naman sa TW, hindi ka agad-agad na nag-absorb ng moisture at di rin siya basta-basta na susunog. Ito namang isa, THW or thermoplastic heat resistant wire, moisture resistant and flame retardant. Dito naman sa THW, halos same lang sila ng TW or yung thermoplastic wire. Is yung kaibahan lang nila is meron siyang heat resistant. Tapos dito naman tayo dito sa THHN or yung thermoplastic high heat resistant nylon coated. Ito naman, halos same lang din sila ng THW. Ito lang naman, yung kaibahan lang nila is high heat resistant na siya tapos naka nylon coated. Tapos dito naman tayo sa THHN/THWN2. THWN is similar to THHN except it is water resistant. Adding the W into the acronym, THWN is rated for up to 167 Fahrenheit or 75 degrees Celsius in wet environments. But its successor, THWN2, is rated for 90 degrees Celsius in both wet and dry environments. Historically, THHN and THWN were separate wires, but now you'll typically find their capabilities combined in the THHN/THWN2 design. Ngayon, dati nabibili mo lang siya separately. Ngayon, pinagsama na sila. Tapos ito na yung halos matibay sa kanilang lahat. Pagdating sa mga wires sa bahay, mga kanakabit mo. Ito na, note. Here's a breakdown to help understand the abbreviations. T stands for thermoplastic insulated cable. H, the wire is heat resistant. HH, the wire is heat resistant and can withstand higher temperature. W, the wire is water resistant. N, the wire is nylon coated. Dito naman tayo sa kasunod, PV wires. This type is an exclusive kind of wire created for PV applications. These cables behave extremely well in very hot temperatures and other harsh environment conditions. Its special characteristics compared to the other wire is its insulation and outer sheet, which is made up of XLPE or EPR. XLPE is an acronym for cross-linked polyethylene. XLPE is a thermosetting polymer, meaning that the material is cured under heat and in that process forms bond in all directions forming a three-dimensional matrix. EPR means ethylene, propylene, rubber. Ngayon, ito namang PB wire na to, ito yung highly durable pagdating sa kahit na anong sakuna tulad ng sunog, ulan, or kahit sobrang init na panahon, is kaya. So, ito yung pinaka-recommend ng mga electrician na gamitin kasi nga napakatibay niya.
So, ito yung sizing dun sa American Wire Gauge or AWG. So, as you can see here, habang bumababa yung number ng gauge natin is mas tumataba or lumalawak yung kanyang circumference. Tapos, ito yung mga gagamitin nating table. Ito yung sa sizing. Siyempre, dito tayo magpo-focus sa copper kasi hindi naman natin masyadong ginagamit yung aluminum. So, dito lang tayo sa copper. I-zoom natin. Ayan, yan. Ito yung sizing. Itong 18 sa 16 hindi masyadong ginagamit kasi masyadong manipis or hindi siya advisable sa PV system. So, dito na tayo mag-start sa 14. Kasi ito pa yung table na gagamitin natin, ambient temperature correction factors based on 30 degrees Celsius or 86 degree Fahrenheit. Yan yung mga gagamitin natin table sa pagko-compute kung anong size ba ng wire yung gagamitin natin sa ating PV system. Tapos ito pa yung isa pang table. Tapos ito pa din. So ito yung steps in PV system conductor sizing. First is look for the ISC rating of PV cell. 2 is to multiply by 2 safety factors, which is yung irradiance and continuous duty. Third is refer on table 310.15 B16 for the size of wire. Yun nga yung pinakita natin kanina. Fourth is refer on table 310.15 B2A for ampacity correction due to ambient temperature more than 30 degrees Celsius. Hindi ko na ulit papakita. Mamaya na kapag nagko-compute tayo, doon na ulit natin pakita yung mga tables para mas maintindihan natin kung saan nanggagaling yung mga numbers dun sa pinag-compute natin. So, fifth is refer on table 310.15 B3C for ambient temperature adjustment due to conduit or SAR distance from the roof. Sixth is refer on table 310.15 B3A for adjustment due to more than 3 wires inside a conduit. 7 is to find the adjustment due to voltage drop. Last, or 8, is the value obtained in the last step will be the basis for the size of wire to be used in the PV system. So, yung sa PV cell, sinasabi natin yan. Dito natin makikita yung ISC. O sa GeneCo, ISC niya is 9.61 amperes. Dito naman kay Jazz Solar, 9.75. Tapos ito pa yung ibang example or example ng PV cell specs. So, dito kay Santec, ang ISC niya is 9.28 amperes. Kay Trina Solar is 8.47 amperes. So, ito yung sample problem natin. Find the proper wire size for a grid-tied PV system consisting of 3 Jazz Solar panels connected in series with specs at the previous slide. So, ito yung gagamitin natin kay Jazz Solar. So, step 1, look for the ISC rating of PV cell. So, as we can see here, ISC, 9.75 amperes. So, ilalagay natin dito, 9.75 amperes. And dahil naka-series nga siya, hindi magbago yung ating current. So, yung current na dumadali sa PV system natin is still 9.75 amperes. Step 2, multiply by 2 factors. Irradiance and continuous duty. ISC natin, ita-times natin siya sa irradiance kasi syempre yung init ng araw, tapos yung continuous duty, yung pag ginagamit natin siya ng tuloy-tuloy. So, 25%. Parehas yan. 25% sa irradiance, 25% sa continuous duty. So, times natin siya sa dalawang 1.25. So, 9.75 amperes times 1.25 times 1.25, 15.23 amperes na yung new ampacity natin. Step 3, refer on table 310.15 B16 for the size of wire. So, tingnan natin kung saan mag-range or saan matatapat yung 15.23 amperes doon sa table na to. So, ito yung table. Ito nga pala yung magnified. So, 15.23. So, lagpas na siya dito. So, dito tayo. Dahil mas maganda pala din sa may THHN. So, dito tayo pupunta kay 90 degrees sa column na 90 degrees Celsius. So, ito, pasok siya sa 25. So, ang tapat niyan is 14. So, yun yung magiging size natin. Kaso, hindi din advisable yung 14 sa PV system. Kaya lilipat tayo din kay 12, which is matatapat na din ngayon sa 30. So, masyado naman malayo yung 15.23 sa 30. Okay lang yun kasi madami pa tayong kukomputin na magpapababa dun sa ampacity ng wire na to. Hindi naman kasi siya exactly na 30. So, itong 30, hindi pa siya fix. Pwede pa siyang bumaba. So, yun nga, sabi natin kanina, diba, tumapat doon sa, pumasok yung 15.23 amperes doon sa number 14 na THHN na merong ampacity na 25 amperes. Kaso, yung 14 nga is hindi siya best practice para sa PV system. So, pinili natin yung 12 na THHN na merong ampacity na 30 amperes. So, step 4, ampacity correction naman due to the ambient temperature. So, sa Pilipinas, ang ambient temperature is around 37 degrees Celsius. So, tingnan natin sa table ng 310.15, 52A, kung saan papasok yung 37 degrees Celsius. So, eto yun. 37, so dito siya sa 3640. Tapos, 90 yung 90 degrees Celsius yung pinili nating wire, THHN. So, pagtapatin lang natin. So, ito, 0.91 yung ita-times natin dun sa ating ampacity ng wire. So, ayun. Dahil 30 yung ampacity nung napili nating wire, ita-times natin siya sa 0.91. So, ang magiging new ampacity na is 27 amperes. Di ba, nabawasan? Kaya okay lang na malaki siya. So, 27 amperes na. Kaso, meron pang adjustment pa ulit due to roof wire distance din sa step 5. So, napili natin is yung 1/2 inch above roof. So, tingnan natin kung ano yung idadagdag natin. So, ito yung dalawang table na nakuha ko. Ito mas latest. Dito tayo magbe-base sa mas latest. So, ang napili natin is 1/2 inch. So, dahil naka-Celsius tayo, ito yung i-add natin, 22. 37 yung temperature, matadagdagan pa ng 22. So, ang magiging ambient temperature natin or new ambient temperature is 59 degrees Celsius. Tapos, titingnan ulit natin dun sa table ng 310.15 B2A kung saan papasok to. 59. So, din siya, 56 to 60. Which is 0.71 yung the times natin. So, ito 27, yun yung new wire ampacity natin. The times natin siya dun sa nakuha natin sa table na 0.71. So, magiging final wire ampacity is 19.17 amperes. O diba, from 30 amperes, naging 19.17 na lang siya. Pero, kahit bumaba na siya, pasok pa rin naman yung ampacity or yung IPV natin doon sa ampacity ng wire. So, yung napili nating number 12 is mag-fit doon sa system. Pero hindi pa tapos yung pagko-compute natin. So, let's move to step 6. And dahil nakaseries siya, and kapag nakaseries, hindi naman na sobra sa dalawang wires yung to-connect natin sa conduit. So, pwede nating skip itong step 6. So, move na tayo sa step 7. Adjustment due to voltage drop, which is yung voltage drop is dapat less than sa 3%. So, ito yung formula. VD equals 2IR, current resistance, wherein yung resistance is equals to K times L over A. wherein yung K is yung direct current constant na 12.9. So, ayan na yun. Okay na yung 12.9. Yung L is length, sabihin natin 25 meters. Tapos, itong A is area ng wire na napili natin. Itong 9.3 is nakuha natin dito, yung maximum power current, IMP. So, ayan, 9.3 amperes. So, ayun siya, 9.3. Ito namang area is nakuha natin dito sa table na to, yung cross-sectional area. So, 12 yung napili natin. So, ito siya, 6,530. Pag sinalpak sa calcu yan, ang lalabas is 0.92 volt. So, para makuha natin yung percentage nung voltage drop niya, itong nakuha natin na tong voltage drop is i-divide natin sa maximum power voltage ng ating PV, which is 32.26 volts. Tapos ito times natin sa 100%. So, ang answer is 2.85%. Since yung 2.85% is mas mababa sa 3%, so pasok siya. So, yung number 12 is mag-fit pa rin siya sa system. Kasi yung nakuha natin na 2.85 is masyadong malapit sa 3. So, mas maganda if bababaan ulit natin yung number ng size ng wire natin. So, gagawin na natin siyang 10 THHN wire para safe na din, and para if ever na magdadagdag tayo ng panels is goods pa rin yung wire natin. Hindi na natin kailangan na bibili na naman ng bagong wires. So, ito yung additional computation. In case, ayan. In case the voltage drop exceeded 3%, kapag ginawang 5% yung voltage drop. Since the initial selected wire is 12, make a 1-step higher adjustment. Select initially, ito nga yung 10 THHN. So, compute ulit tayo. 2, tapos ito yung 9.3, tapos ito yung constant ng direct current, 25 meters pa rin. Itong 10,380, dahil nga nag-10 tayo, ito yung 10, ito yung magiging area natin, 10,380. So, magiging sagot is 0.058 volts. Tapos, ganun lang din ulit kanina. I-divide natin dun sa voltage ng PV cell. Tapos, times sa 100, makuha natin yung percentage ng voltage drop niya, which is 0.18%. So, ala pa siyang 1%. So, pasok lang siya or mababa siya dun sa 3% or 5% na voltage drop. So, pwede natin piliin yung number 10, THHN, as the final wire to be used in the system. So, note, ito nga sabi ko kanina, yung K is the direct current constant. This is a constant representing the direct current resistance for a 1,000 circular Mills conductor that's 1,000 feet long, an operating temperature of 75 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms. Ito nga ginamit natin kanina. And 21.2 ohms for aluminum. And hindi natin masyadong ginagamit yung aluminum. So, kahit di natin ito pansinin. The K constant is suitable for alternating current circuits where the conductors do not exceed number 1/0. Kahit 90 yung ginamit natin kanina, dahil THHN nga siya, okay lang daw yun. Kahit na mapa 60 degrees Celsius siya, ito lang laging gagamitin. 12.9 ohms. So kung if ever na ayaw mo namang mag-compute pa ng kay komplikado, merong mga tables sa internet na mabilis na lang makita kung anong size ng wire yung gagamitin mo. Hindi mo na kailangan mag-compute pa. So, ito yung mga example niya. Yan. Yan pa. Ayan. Madami pa sa internet. Yan lang yung kinuha ko. So, moving on. Ito naman tayo sa circuit breaker sizing. Ang gagamitin natin is etong table na to. Eto lang. So, magbigay na tayong example. DC-AC circuit breaker sizing. First thing to consider, kapag nag-sizing tayo ng circuit breaker is yung ruling ng PEC, which states that the minimum OCPD rating is 125% of the maximum current. So, di ba kanina ang current natin is 15.23 amperes. So, multiply natin siya sa 125%. So, ang sagot is 19.04. O, tingnan natin ngayon sa table. 19.04. Pasok siya sa 20. Kaso, masyado siyang malapit ulit. So, mag-a-adjust tayo din sa 25. Kaya 25 yung gagamitin natin sa circuit breaker ng DC. So, sa AC side naman, assume lang na yung inverter natin is 1.5 kilowatts. Tapos, meron siyang current na 12 amperes. Multiply natin sa 125%. So, ang sagot is 15. Tingnan ulit natin sa table. 15, eto, saktong-sakto naman masyado. So, mag-move tayo din sa 20. Parang katulad na kanina, move tayo dito kasi masyado malapit. Ito, sakto. Kaya move tayo sa 20. So, eto. Gagawin natin yung 20 amperes na circuit breaker sa AC side. Moving on, eto yung surge protection device sizing naman. Dine daw, simple lang yung rule. Basically, yung UC rating ng SPD is dapat mag-match dun sa system voltage or mas mataas ng 15 to 25%. Para yung SPD natin is mas matagal pa yung buhay or hindi agad masira. Kasi pag sakto yung nilagay natin na SPD or sakto dun sa voltage ng system, as in saktong-sakto, lagi na lang magtitrip yung ating SPD. Kasi lagi siya makakadetect ng transient voltage. So, dapat mas mataas ng 15% to 25% para hindi na lang laging nagtitrip. Yun yung magiging dahilan para mas madali siyang masira. Kasi yung SPD is meron din niyang wear and tear. Ang nga pala, yung UC rating, ito yan, Maximum Continuous Operating Voltage or MCOV. Tapos yung IN naman, Nominal Discharge Current, IMAX, Maximum Discharge Current, UP Voltage Protection Rating or Surge Voltage Rating or Clamping Voltage. So, dito na tayo sa DC side. Diba yung DC side natin kanina yung sa PV cell natin, ang rating niya is, ang voltage niya is 32.26. At di ba tatlong PV cell yung gagamitin natin? So, sabihin natin mga nasa 90 pataas yun. So, dapat ang gagamitin nating SPD is meron siyang UC rating na 100 to 120 volts para mas mataas doon sa system voltage natin. Sa AC side naman, 220 volts yung meron. Ang gagamitin nating SPD sa kanya is yung may UC rating na 230 or pataas pa hanggang 275 volts. So, dito nga pala natin makikita yung UC rating niya. Ito sa DC, ayan, 800 volts. Ito naman yung sa AC SPD, meron siyang 275 volts. Doon lang titignan yan. Madali lang mahanap yung mga nakalagay naman lahat yung details niya, yung mga volts, amperes, mga ganun sa mga SPD natin, sa mga devices. So, moving on, zero bill computation naman tayo. Let's say, 300 kilowatt-hour per month yung gastos sa bahay nyo. So, kailangan natin computein kung ilang solar panel ba yung kailangan. So, convert muna natin siya sa daily usage. So, per month is meron tayong approximately 30 days. So, divide natin sa 30 days para maging per day siya. 10 kilowatt-hour per day na. Or equals din siya sa 10,000 watt-hour per day. Tapos, i-divide natin to sa oras. Kung kailan maganda yung sikat ng araw sa Pilipinas o sa lugar natin. As we can see here sa picture, ito like color, dalawa lang, which is 4.5 to 5, tapos 5 to 5.5. So, ang average is 5. So, i-divide natin siya sa 5 hour per day. Yung 10,000 watt hour per day natin. Yun yung magiging solar RE rating natin, which is 2,000 watts. Dahil hindi naman maganda yung sakto nga, lagi tayong mag-a-adjust ng konting-konti lang, slide lang. So, sabihin natin 10% yung i-add natin. So, times natin sa 1.1. So, ito na yung assurance natin sa zero bill. 2,200 watts. Para malaman natin kung ilang panels, yung per panel, sabihin natin 300 watts ang meron siya. So, di-divide natin. Ang sagot is 7.33. Hindi naman pwedeng ganyan yung number ng panels natin. So, gawin na natin siyang 8 solar panels. So, pag 300 kilowatt hour per month yung gastos nyo sa bahay, or yung consumption nyo sa bahay, is 8 solar panels yung kakailanganin mo. Ganun lang kadali mag-compute. So, thank you for watching. Goodbye!